Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and during this segment, we're going to get into a quasi-industrial engineering topic and a business topic. Now, as you know, I'm going to school at Purdue University, and I'm in their industrial engineering program or industrial engineering technology. Now, the industrial engineering technology program is very unique. And this is why it's unique. When you deal with mechanical, civil, electrical, and of course, chemical engineering, you're basically dealing with a section. You're not dealing with a whole, or we can say a component. Now, with mechanical, civil, and of course, electrical. Well, let's go back and just say civil, mechanical, and chemical. You can actually see what you're designing. Electrical, you can't. That's why it's one of the hardest branches of engineering, because everything is theoretical. Laplace transforms, signal processing. But again, this video is about a subject of industrial engineering. And what makes industrial engineering very unique is because you take a whole system. You utilize optimization, and there is some mechanical and electrical involved as well. But I'm going to break it down even further, and we're going to talk about operations management. Now, when we deal with, of course, operations management, it's an area in management that is concerned with designing and controlling the process of production and redesigning business operations in the production of goods and services. Now, it involves the responsibility of ensuring that business operations are efficient in terms of using a few resources as needed and effective in meeting customer requirements. Now, it is concerned with managing an entire production or service system, which is the process that converts inputs. Now, inputs are basically in the form of labor, consumers, and raw materials and energy into outputs in the form of goods and services for customers. Now, operations produce products, manage quality, and create services. Operation management covers sectors like banking systems, hospitals, companies, working with suppliers, customers, and utilizing technology. Now, operations is one of the major functions in an organization along with supply chains, marketing, finance, and human services, because the operation function requires management of both the strategic and day-to-day production of goods and services. Now, in managing manufacturing or service operations, several types of decisions are made, including operations strategy, product design, process design, quality management, capacity, facilities planning, production planning, and inventory control. Why? Because each of these requires the ability to analyze the current situation and find better solutions to improve the effectiveness and efficiency of manufacturing or service operations. Now, a modern integrated vision of the many aspects of operations management may be found in recent textbooks on the subject. Now, again, when we deal with operations management, let's go back to a few, like to the Industrial Revolution. Now, the Industrial Revolution work was mainly done through two systems: domestic system, and craft guilds. Now, in the domestic system, merchants took materials to homes where artisans performed the necessary work. Craft guilds, on the other hand, were associations of artisans which passed the work from one shop to another. For example, leather was tanned by a tanner, passed to couriers, and finally arrived at shoemakers and saddlers. Now, the beginning of the Industrial Revolution is usually associated with 18th century textile English industry with the invention of the flying shuttle by John Kay back in 1733. Now, the spinning jenny by James Hargreaves in 1865, the water frame by Richard Arkwright in 1769, and of course, the steam engine by James Watt in 1765. Now, in 1851, at the Crystal Palace exhibition, the term American System of Manufacturing. The American System of Manufacturing was basically used to describe the new approach that was evolving in the United States of America, which was based on two central features: interchangeable parts and extensive use of mechanization to produce them. Now, during the second industrial revolution and post-industrial society, Henry Ford was 39 years old when he founded the Ford Motor Company in 1903 with $28,000 capital from 12 investors. Now, the Model T was introduced in 1908. However, it was not until Ford implemented the assembly line that his vision of making a popular car affordable by every middle-class American citizen would be realized. So the first factory in which Henry Ford used the concept of the assembly line was Highland Park, 1913, where he characterized the system as follows: to keep everything in motion and take the work to the man and not the man to the work. This is the real principle of our production, and conveyors are only one of many means to an end. This became one of the central ideas that led to mass production. So one of the main elements of the second industrial revolution, along with the emergence of the electrical industry and petroleum industry. Now, the post-industrial economy was noted in 1973 by Daniel Bell. He stated that the future economy would provide more GDP, which stands for gross domestic product, and employment from services than from manufacturing, and have a great effect on society. Since all sectors are highly interconnected, this did not reflect less importance for manufacturing, architecture, and mining, but just a shift in the type of economic activity. Now, what does all that mean? Well, this is what started production. Now, you have to remember, even before we went to the Industrial Revolution, the United States of America based its economy off of agriculture. So, but what Henry Ford did, this is where operations management comes into place. Although productivity benefited from technological inventions considerably, and of course, the division of labor, the problem of systematic measurement of performances and a calculation of these by the use of formulas remained somewhat unexplored until Frederick Taylor, whose early work focused on developing what he called a differential piece rate system and a series of experiments, measurements, and formulas dealing with cutting metals and manual labor. Now, the differential piece rate system consisted in offering two different pay rates for doing a job: a higher rate for workers with higher or high productivity or efficiency, and who produced high quality goods, which is known as effectiveness, and a lower rate for those who failed to achieve the standard. One of the problems Taylor believed could be solved with the system was the problem of soldering. Faster workers reduced their production rate to that of a slower worker. So in 1911, Taylor published his Principles of Scientific Management, in which he characterized scientific management, also known as Taylorism, as the development of a true science, the scientific selection of the worker, the scientific education and development of the worker. And also, he had intimate, friendly cooperation between the management and the workers. So Taylor is also credited for developing stopwatch time study. This combined with Frank and Lillian Gilbreth motion study. Now, if you don't know who Frank and Lillian Gilbreth were, they were the pioneers of industrial engineering. In fact, Lillian Gilbreth, I believe, started the industrial engineering department here in my home state of Indiana at Purdue University. And of course, they were the ones that had something to do with motion study, which gave way to time, and motion study, which is centered on the concepts of standard method and standard time. Frank Gilbert is also responsible for introducing the flow process chart in 1921. Other contemporaries of Taylor worth remembering are Morris Cook, rural electrification in the 1920s, and the implementer of Taylor's principles of scientific management in the Philadelphia's Department of Public Works. Karl Barth, speed and feed calculating slide rules. And of course, my favorite, Henry Gantt. Now, Henry Gantt was from my state of Maryland, and I believe he graduated from Johns Hopkins University. Now, if you don't know who Henry Gantt was, if you are in any type of project management, you see what we call a Gantt chart. He was the architect of the Gantt chart. And also in 1910, Hugo Daimer published the first industrial engineering book, Factory Organization and Administration. So in 1913, Ford Whitman Harris published his How Many Parts to Make It Once, in which he presented the idea of economic order quality model. So what I'm saying when it comes to operations management, and I'm not going to go through everything here. You can definitely look this up yourself, but there are some things that go in operations management: transportation, optimization, going down. You have service industries. They're also part of economic activity, mathematical modeling, linear programming. That's also part of operations management, safety, risk, and maintenance. Now, this is definitely important if you are in the field of industrial engineering. Now, a number of people don't know about industrial engineering, but the names that you heard of, Frank and Lillian Gilbreth, you heard of Henry Gantt. Going back to industrial engineering, operations management is part of industrial engineering. Now, you heard the stopwatch. Well, operations management was put into place to basically look at the efficiency of work. How do you solve the problem? How do you make your workplace better? So bringing that all together, this is where you have industrial engineering. And Penn State University was the first school to actually teach industrial engineering. They had first department. Now, why am I bringing all this up? Well, I'm bringing all this up because when you deal with industrial engineering, operations management, there's a lot of statistics involved. You're going to see a lot of funny charts like Pareto charts, cause and effect charts known as fishbone diagrams. I'll get to those later because I actually drew some fishbone diagrams. But when you get into operations management, industrial engineering, you'll be designing experiments, supply chain management, is also part. Basically, when you deal with operations management, you're managing people, information, resources, energy. I'm gonna do another video on lean manufacturing, reducing waste. But going back to operations management, basically what you're doing, you're utilizing optimization, linear programming, transportation. You're trying to make an organization better, reducing waste. You're working with people. Again, you have human resources, you have energy. All in all, operations management is a sub-discipline of industrial engineering, and it's also used in business. Now, when it comes to business, it's less mathematical. And when it comes to engineering, it's a little bit more mathematical. But in the end, operations management is a sub-discipline of industrial engineering. And if you want to know more about operations management, take the course for yourself at your local community college or university. You will find the course very interesting because it is a mixture of business and engineering, math, and engineering and math. Operations management. It's not just for the manufacturing sector, but it's for the service sector as well. And that concludes this topic on operations management from the Mind of STEM channel. On this channel, you get a daily dose of science, technology, engineering, and math. And if you want to see more of my videos and you can't find me on YouTube, check me out on Twitter and, of course, LinkedIn. And once again, I thank you for listening to this topic on operations management. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious night.